We move to question number 3. We want to derive an equation for the position of the car as a function of time. We want to identify the value of the position as t is equal to 0 and the asymptote of the function x of t as t goes to infinity. We know that v of t equals a times 1 minus e to the power of minus small t over capital T. We expand this quantity, we expand the brackets. Since we want to find the position, we have to integrate both sides with respect to the variable t. We integrate, so at the left hand side of the equation we get x of t. The integral at the right hand side, the first integral is just a times t minus a times the integral of e to the minus t over capital T is going to be e to the minus t over capital T over minus 1 over capital T plus the constant of integration c here, because we do indefinite integration, is a times t plus a times capital T times e to the minus small t over capital T plus c. Because v0 is equal 0, it means that the initial speed is equal to 0. The initial positions x0, since it still is going to be equal to 0. The velocity of the car for t equals 0 is 0, so it's not moving, so the initial position is going to be x0 equals 0, and from here we can find the constant c. So 0 equals, this term is going to vanish, this term is a times capital T plus c, and from here the constant c is going to be minus a times t. Let's go back to the formula here and plug c equals minus a times t, and we get the final expression for the function of the position of the car. So we're going to have x of t equals a times t, small t, minus a times t, capital T, plus this term involving the exponential function. Alright, that's my formula. Now, of course, I can find x0 is going to give me 0. I can verify this. And now I need to find the asymptote of the function as t goes to infinity. So the asymptote, let's go have a look at this function. We have x of t equals a times t minus a times capital T plus a times capital T e to the minus t over t. Let's notice the following. When you take the limit as t grows, as time grows, so as time becomes large enough, the a times t e to the minus t over capital T is going to go to 0, because the exponential will go to 0 times a constant a times t. So that term, as t grows, that term is going to vanish, and you will have x of t equals a times t minus a times capital T for t growing sufficiently large. So it's going to be the oblique, there's going to be oblique asymptote of the form y of t equals a times t minus a capital A times capital T. This is going to be the oblique asymptote of this function. Okay, so it's going to look like this. For t equals 0, we find the y-intercept is going to be minus a times t, and for y equals 0, we have a times t minus a times capital T equals 0, so t is going to be equal to capital T. So the straight line is going to look like this, and that is going to be the oblique asymptote. Okay, this is called oblique asymptote.